Section 409. Classwork. General PDF files and exercises and answers. Exercises, old exam papers, here answers. Open. Page 1. Page 2. 9. A business school accrediting agency has developed an outcomes measure test for graduating business school students. The test asks last semester seniors a number of questions about topics in business and economics that they have studied during their coursework. At one school, a random sample of 13 students took the test. Included in this group were 4 marketing majors, 4 management majors, and 5 accounting majors. The data on test scores can be assumed to be normally distributed with equal variance. At 5% level, perform a test to determine whether there is no difference in average scores among the 3 academic majors. So the question is to compare 3 mean scores. 3 mean scores of 3 majors. So this is ANOVA. And to confirm, check if the 3 samples are independent or not. You can see that the sample size n is 13 and sample 1 size is marketing majors for 4 scores of 4 students, 4 management majors, 4 scores of 4 students, 5 accounting majors, 5 scores of 5 students. So different students, different groups, totally different groups. So independent samples, correct. And there are 2 ANOVAs. Parametric ANOVA, this is called one-way ANOVA, and non-parametric ANOVA, this is called Kruskal-Wallis ANOVA or Kruskal-Wallis test for analysis of variance. Topic 6. The data can be assumed normal, normal and equal variance for 3 samples. So that means the data and the population of scores is good enough for parametric tests. Therefore, we have to choose one-way ANOVA. Topic 3. ANOVA. 10. A statistics professor taught 2 special sections of a basic course in which the 10 students in each section were considered outstanding. 10 students, 2 sections. Okay, she used a traditional method of instruction in one section and an experimental method in another. So 2 different, totally disjoint groups of students. One is traditional, another experiment. So he will measure 2 independent samples. At the end of the semester, she ranked the students. So ranking means ordinary measurement. Therefore, this is for non-parametric tests. You cannot use parametric tests. Parametric tests require interval level or interval at least. Therefore, interval or ratio on the basis of their performance from 1 to 20, worst to best. Okay, 1 means worst, 20 means best. So big number means good. These rank ordered data are used in the test of hypothesis to determine whether there is a significant difference. Different or not, that is, different means HA in the performance of students between the two teaching methods. To compare two teaching methods, the professor will compare two scores of two totally disjoint groups, independent samples. So this is to compare two means. Independent samples, you compare two means. And level of measurement is ordinal ranking. Therefore, there are two parametric test is independent samples. Non-parametric test is Wilcoxon. So this is ordinary level. Therefore, non-parametric test, Wilcoxon test you must use. Mann-Whitney Wilcoxon rank sum test. 11. The advertising manager of a breakfast cereal company would like to determine whether a new package shape would improve sales of the product. In order to test the feasibility of the new package shape, a sample of 20 equivalent stores were selected and 10 were randomly assigned as the test market of the new package shape. Whether the other 10 are to continue receiving the old package shape. The data on sales of product can be assumed to be normally distributed. So, normally distributed, that means we have to choose parametric test. Topics 1, 2, 3, simple regression, multiple regression, ANOVA. The set outputs are given, so you have to select the correct set output. Now, how many samples? 2 samples, independent samples, new package shape and old package shape, 10 each. So 2 disjoint groups, independent samples. So we can say one variable is package shape. Package shape. One variable is package shape. The variable package shape has two values. One is new package shape, another is old one. Okay. After the test variable, for these two groups, what did they compare? They compare sales. Sales you see here. You can see here the data on sales of the product. The sales can be sales. So how many packages sold and or amount of money, anyway, ratio level measurement, and normally distributed. Therefore, you can use parametric tests, and parametric tests are usually better. So compare two independent samples, parametric test. Therefore, 2 means independent samples t-test. Okay. One tail or two tail, here you see a new package shape would improve sales of the product. That means new package shape has higher sales. mu1. For new package shape is greater than mu2. Old package shape is A. Okay. Right tail test. Now you can choose set outputs. 12. In a study concerning sex discrimination in the salary earnings of workers in a particular industry, this is the common thinking and common test. Male and female, male get more salary. This is true usually. Sex discrimination. A random sample of 15 workers, sample size 15, is selected from a pool of employed laborers. And the workers' average monthly salaries in thousands of dollars are determined. So One variable, the variable is monthly salary, measurement level, $1,000, ratio level. Along with their age, another variable is age. Yeah, for each worker, there are two variables determined: average monthly salary and age in years. So ratio level measurement. Another variable is gender. Gender is male or female. So nominal level measurement. Two values, they are male or female. So in this study, there are three variables: salary, monthly salary, age, gender. The first two are ratio level. The third one is nominal with two values. A gender can be only male or female. This variable is a dummy variable. So dummy variable refers to multiple regression requiring 0 or 1 coding, right? Suppose we arbitrarily let 1 denote male and 0 denote female, okay, coding. The set multiple regression outputs developed from the data given in Appendix A. Several set outputs are given in Appendix A. Choose one of them to answer the following question. Okay, to choose the correct answer, you have to choose multiple regression, linear regression output. Sample size must be 15 and variable names must be monthly salary, age, gender. Okay, 3. So sample size, variables, and test name, and these 3 will give you the correct choice. Topic 2. The thing is, social researcher is interested in surveying attitudes of high school students. Okay, psychometric measurement concerning the importance of getting a college degree. Okay, she questioned a sample of 60 high school seniors about whether they believe that a college education is becoming more important, yeah, than before, less important, or staying the same. 3 choices, yeah. So that means each high school senior have to answer this question, and there are 3 choices. Nominal measurement, yeah? The variable is attitude or opinion. One variable, nominal measurement, and the question is if the responses are equally divided across the 3 categories. Therefore, this is to compare frequencies, percentages, proportions, 3 proportions of 3 divisions of the population. Therefore, this is chi-square goodness of fit that for multinomial variable equal expected frequency case. So variable name, and there are 3 values, more important, less important, or staying the same, and variable name is attitude. Okay, 3 values, the names of 3 values are more important, less important, staying the same, and sample size is 60, and test name is chi-square goodness of fit test. So by these facts you can choose the correct output.